So, we officially have 1,000 miles on the sniper. If you're keen enough, you'll go back and look at the odometer in the install video when I first started, and it was at 4161. We are now at 5167, so we're just over 1,000 miles. So what I'm going to do is take you through the things that have been changed, settings that have been updated. It runs fine out of the box. I will say the one thing that you really do have to be careful of, the timing is way too aggressive out of the box. I'm not as familiar with what these motors like. They like less timing than what I'm used to. I'm working on small and big block Chevys. They like a lot of timing, especially big blocks. They like 36, 38 degrees of advance under load. That I started, I think, at 34 total. Way too much. It was pinging, it was knocking, and actually, there's a very well known guy on the Vintage Six forum who has probably one of the hottest inline sixes out there, and he is really good with the sniper software. I would have figured it out eventually, but he already had the timing map for a stock inline six that got it really close. So he went ahead and just dropped that timing map into my file for me, and that solved the pinging problem. So let me turn the key on, and we'll just kind of go through the menu, and I'm going to talk about some of the things that have been changed. And maybe what I'll do, since it's a little hard to see it on the handheld, I'll open up the sniper file in my computer, and I'll show you maybe a data log and kind of where it's at. It's not perfect, but for this motor, it's making plenty of power. It's doing just fine. So yeah, let me turn the key on here and get the screen booted up. All right, so I actually fired it up here because it doesn't really matter, but figured I'd start it. So this is just the vital screen. This is kind of the one that I leave up. There are a number of other options you can do with this. Just, you can look that up, but you can customize a gauge panel, and there's a few of them in here. You can customize these. I think I set this one up as one that's showing me my timing. Because also, if you've only seen the original video, I did add the Hyperspark to this. There is another video that has the Hyperspark install. I'll go ahead and put a link right up here for the Hyperspark video in case you're interested in that. So let's take a look at some of the things that we've changed and some of the things that are kind of interesting about the sniper. We'll go to tuning here. I'm a lot more familiar with this menu now that I've been through it a bunch of times. You're going to notice some things, though, in here that are not available from this screen because they have been customized using the software, and I'm no longer using the base files. One of them is timing. The other one is the AFR table. Didn't change anything in here, really. The only thing I've got set up in here is my fans. I only have one fan, and I did the auto cool controller, which mainly handles the temperature. This is a backup is all it is. If it gets up to 200 degrees, it turns the fan on 100% because I have a variable speed controller in there. Okay. Let's go to basic and basic fuel and target AFR. You're going to see it says not available in here. That's because it has a customized table. That's also something that I had a little bit of help with. It wasn't something that was absolutely necessary at all. It just gave the table gives it a better curve of the AFRs. Otherwise, it just interpolates between idle, cruise, and wide open throttle. It kind of gives one curve for that. It has a little bit more customized curve in it now. I also did not do that. So I had help with that, and I had help with the timing table. Now, I will go over when we get to looking at the screen on the computer. I can show you the things that I have changed in the fuel table. And based on running... Sorry, I want to say the word trend because that's something that you run in the automation world. So it's kind of like a trend. It's a data log. They call them data logs on here. So anyways, you'll notice that those aren't available because you can't change that now. You have to use the sniper software to change that. I have played with the Excel enrichment just a little bit. Based on looking at the data log, I went and I played around with this a lot. It out of the box was 6.4 pounds an hour. I bumped it up to 6.6 to get, there was just, you couldn't even tell when you were driving it, but if you looked at the data log, there was a spike, a lean spike on acceleration. So I just bumped that up just a hair, and it doesn't take much. 2 points there, and it's kind of right in line. Spark, same thing. It's a customized table. The only thing that you can change is your ignition timing. Typically, this is going to be a little bit lower, less advanced. It makes it easier to crank. This thing's idling somewhere in the neighborhood of 14 to 16 degrees. Now, it varies that because it varies because the Hyperspark is computer controlled. It varies the idle timing to stabilize the idle, which gives it a much better idle than this thing ever had before. Before when it was carbureted with a standard mechanical advance. Mechanical advance, especially if they have light springs in them, like if you're doing, if you have a higher performance setup where you want a quick timing curve, they have a tendency to oscillate because the springs will go out, the ignition timing bumps, and then the fuel injection, if you're running a fuel injection unit, that is, with mechanical timing, the fuel injection will try and compensate and bring the IAC down, and they oscillate. My truck was doing that until I put the DIS system in that. Let me see, what else did we change in here? Idle, just 750 RPM is where this thing wants to live at. It's higher than what the manual says, but it's just where this is happy. I didn't change anything in there. In advanced, I have taken the learned compensation down to 7%. So you don't have to do this. However, it's set at 50% normally, so it can compensate up to 50% over or under wherever it's at. So if your AFR has a target and it's 50% under, it'll try and compensate up to 50%. Now that this thing's learned over 1,000 miles and I've transferred the learn table a bunch of times, I've taken this down to where it just allows just a minimal, and I did this across the board. In the software, you can kind of tell it where you want the learn compensation to be more or less. I just set across the board based on how much it's learning now. I don't want it to exceed 7%. And the reason for that is in case something changes, like your O2 goes bad, or something has changed in the system, the regulator goes bad, and the fuel pressure regulator goes bad, something, you don't want it to start learning bad data. You don't want it to start taking fuel out because the fuel pressure is too high. You want it to only try and compensate using the O2 sensor. You don't want your base file to get destroyed because something else went wrong. So that's kind of the reason they want you to limit that. So like I said, I got it at 7%. I haven't turned it off yet because it is still learning. It's learning 2 or 3% in some areas. Some areas it couldn't learn out of it, and I'll show you those, mainly wide open throttle runs. It couldn't learn out of it. I had to deduct 5-10% in some places. Let me see if there's anything else in here that is worth talking about. I didn't change anything here. A while ago, back when it was fresh, I did change the ramp down a little bit. I increased the ramp decay. It was decaying a little bit too fast. So this was like 4 seconds, and it would actually stall every once in a while because it was dropping too quick. So I went ahead and I changed that to 6 seconds. I left it at 20% hold position, and I disabled AC kick. The AC kick is something, it's supposed to kick up the idle if your AC compressor turns on. And I have AC in this thing, and it was affecting it a little bit. It was trying to do it. So I changed that to 0%, and I disabled it using the sniper software. There's more options. Unlike, if you're a Phytech guy, everything from the Phytech, just about, unless you really need to do some serious tuning stuff, everything can be done from the handheld. The sniper is very limited. It's very limited on the handheld, but they do give you the software. It's free. So you do have to go in and use the software if you really want to get in, if you really want to dig into this and get it right. It's kind of a requirement, I would say. Nothing else in here. I don't think I changed anything here. Advanced 2, nothing. I didn't change a thing in here in the advanced file. Logging becomes very handy. I use this a lot to kind of troubleshoot the performance. I could tell it was a little bit sluggish. So it definitely had some really rich spots in it. So I went ahead and fixed those. Some of them it was learning out, some of them it wasn't. File, global configs. This you can download from the ECU and it'll write over the file if you want, or you can rename it, or you can upload to the ECU. I have downloaded and uploaded numerous times because anytime you take it to your laptop to go make some changes to it, you got to re-upload it to the system. It's not a big deal. It's very fast, very efficient, no problems. So that is going to pretty much cover it for what I did here. So maybe what I'll do is I'll go jump on the computer and we'll take a look at what the log looks like, one of the latest logs. Actually, there's two of them that I just took in this because I'm still playing with the base fuel table a little bit that I haven't even looked at yet. So we'll go ahead and we'll take a look at all that. You'll also notice the temperature's just rock solid. It sits there where I've got my auto cool controller set. It holds at 190 like all the time. It's either at 190 or below, which is absolutely fine. Usually if I'm cruising, it's about 180, 182. I'm sitting here, it's been idling for quite some time, and I just had it up on the freeway and everything. You can see it's just rock solid. I'll say it again. I highly recommend those controllers for if you're running an electric fan. Absolutely want to run those. Oh, I'll mention one more thing too. I have noticed, and I don't know if this is specific to the 1100 unit, the lower the IAC is, the better this thing the smoother this thing wants to idle. I think I can kind of estimate why that is. Your IAC air kind of comes in the side of the Venturi, whereas your butterfly is pulling the air directly down rather than the air going in the side and bypassing the Venturi. I think that gets you a better fuel mixture. The lower the IAC is, like I had it up, the limit's 2 to 10%. I had it up closer to 10%. This thing was idling a little bit more rough. I've had it down. I had it adjusted down, but I've played with a couple things, so that's probably why it's a little bit higher. I had it closer to like 3-4%, and this thing was idling so smooth. So, I think that's just a little takeaway there. I think you want your nominal idle in park, by the way, or out of gear, in neutral. You want that number closer to the 2% range, I think. I'm probably going to readjust this. So anyways, let's go take a look at the files. All right, let's take a look at this latest data log that we got here. This was a rolling start. So it actually downshifted right here. That's what this is, our engine RPM. If you're not familiar with this, it's funny. It's all color coded and everything. Well, that's a real pain in the ass for folks like me that are colorblind, because a lot of these colors look similar. Colorblind doesn't mean I don't see colors. There's a common misconception. Some colors look very similar, like these two, whatever these two are. I think blue and pink or purple. Who knows? I don't know. Blue and purple are very similar. I digress. Anyways, you can turn on and off the different options here. So you can, like, if there's data in your way, you can turn them on and off, depending on what it is you want to see. I've gotten pretty familiar with what this looks like now. What these two lines are right here is my target air-fuel ratio and my actual air-fuel ratio. And you'll notice in this particular run, this is pretty good. I tipped out right here, what you would call tip out. That's why it's all crazy right here. And I was I coasted for a while. Don't pay any attention to any of that. This is what's important right here. This is the performance curve right here. So this is RPM. This is closed loop compensation right here, this little yellow line. I think it's yellow. I think yellow, green, I think. Like I said, I struggle with this. But anyways, this is closed loop compensation. What you want, the whole idea here, if you guys don't know this, you want your base fuel map to be as close to all the conditions that it sees in the real world as possible. And you want your oxygen sensor doing as little correction as possible. Because if you have your base fuel table really close, it doesn't have to take any time to compensate, and it doesn't have to remove or add any fuel. And that all costs time and it costs power, right? You want it to be really close. And also, if your oxygen sensor ever takes a dump, you can turn off closed loop and still drive it, because under most conditions, the base fuel table is going to be really close. You'll notice here, this the most that this deviates, and if you click on these, if you click on each line, it'll show you at the top what it is. And I don't know if this is going to come out or not, but you'll notice the most closed loop compensation I had was 2%. That's pretty good. That's pretty darn good. And you'll notice my air fuel ratio isn't all over the place. It's pretty much in line with what the command is versus, I would call this, in my world, control systems guy here, I would call this command monitor, right? So we're commanding it at some AFR and we're monitoring it. At wide open throttle, I'm running this thing right around 12.2, 12.3. It depends on what the map is, and that's why I'll show you the base fuel table in a second and how that's been modified. And but pretty much the lowest AFR that I can have is 12.1. Which it never gets there because you'd have to be at 105 kPa, which will never happen. So it's always going to be, it's usually 12.2, 12.3 right in there. That seems to be where this engine makes the most power. It's also the fuel that we have here too, because it's not, I was told it was tuned, or that the air fuel ratio was lambda, but I don't think that it is because, I don't know. A lot of people tune to lambda. The Phytech, you can do that. I'm not sure about in the Sniper. I just know that it has an AFR table, and I compensated for our 10% ethanol fuel. That's all we have here in California, which means instead of 14.7 stoke, you're going to be at 14, just over 14 stoke because it's 10% ethanol. So anyways, my table is based on that. So my table won't necessarily work for you guys. It works for me. I was running at 12.5 and you could just feel it just was lagging. You could just feel it. So I don't have a dyno, so I'm kind of going off of what I think. Remember, this isn't going to tell you how much horsepower you're making. It's just going to tell you if you're where you're telling it to be. Okay, maybe that's the easiest way to say that. I'm telling it to be somewhere. It's trying to make sure that it's there. It doesn't necessarily mean that that's right. It may want 12.1 when I'm telling it to be at 12.3. I'm doing this off the seat of my pants. I got a pretty good feel for what it should feel like, and what it should look like. This thing is making probably the most horsepower that it can. These things were not very powerful. It's just the head seriously limits the power that it can make. But anyways, you can see kind of what's going on here. It looks pretty good. You have coolant temp right up here. This, I think, is map here. Yep, that's map. So you can tell is at wide open throttle because it's at 96 kPa. RPM. You can turn on other stuff. You turn on fuel flow, which I think is estimated. I think it knows by the injector duty cycle. It shows you the duty cycle of the injectors. Mass air temperature, which I don't think that this thing has. Oh yeah, it does. I don't know if that looks like that line's pretty static to me though. It says 60. I don't know that ever changed. I'm not sure if this thing uses MAT or not. I think mass air temperature, is that right? Might be. I forget. MAF would be mass airflow. Anyways, you can kind of see all the things that are on there, but this is what it should look like. So if you start seeing your actual AFR is way lean, if it's above this line, it's lean. If it's below this line, which is your command, right? If it's above it, it's lean. If it's below it, it's rich. I'll show you what a bad, I don't want to say bad, just not optimum looks like. So this looks pretty good. This is kind of what it should look like. By the way, this is totally normal right here. It got a real lean spike until the acceleration kicks in, the acceleration enrichment. I could probably do a little bit better with that, but then again, like I said, it downshifted. And what you don't want to do is it'll if you go too rich, then it's going to swing low, and then it's going to try and compensate, and you'll get an oscillation in here. You don't want that to happen. So it's not bogging and it's not lagging, so I know that my acceleration enrichment is correct. So this, like I said, this looks pretty damn good. So let me open up one that is probably not so optimum, and it's going to be one of my early logs. All right, here we go. Here's one that's pretty jacked up. So this is the command right here. This is the actual. you can see I was rich here, and then it swings and it goes lean, and then it's very rich. And this is, I kind of battled this area the most. This was pretty easy to fix. This, I tried to let it learn out of it, and it really didn't want to learn out of this. It was, but really slowly. And then every time you smooth it, it takes out, I'll back up for a second. It would learn, but not as far off as it was. So if it was off by 6%, it would learn 4%. And then I would transfer the learn and I'd smooth it one time, and I'll show you that. I'll show you what smoothing it does. Well, I don't want, well, maybe I will. We'll see. Look, I'm not going to teach you guys how to do everything. I'm just telling you, if you got a 200 inline 6 and you're running the Sniper 1100, these are the things that I saw and that you may have to correct. Your engine you may get a totally different result. And I know there's a few of you that are really following this closely because you're getting ready to install them. So I'm just showing you what I battled. Obviously it's too rich here. This is like, I want to say this is like 11.8, 11.9, 11.7. Yeah, this is 11.7 right here. So I tried to let it learn out of this, and it just wouldn't. So I went into the base fuel table in my file, and I selected this area, and I dropped it like, I don't know, 8%. And then I smoothed it. And then I think I went in and I took another percent out or so. Same thing here. And by the way, fixing this, and I knew that this probably would happen. That's why I didn't play with this lean condition right here. It oscillated. That's kind of what I thought. It was compensating, right? It tried to compensate and overcompensated. That's why it's up here. Okay. I fixed this, which fixed this. If that doesn't make sense to you, that's okay. Remember, the thing's just trying to adjust, and sometimes it overshoots, right? That's why this happened right here. As soon as I fixed this, it fixed this. This was a big problem area right here. I could tell that it was running fat, and it just wasn't running right. So once I tuned that out, it fixed it. But that's what a bad, well, I shouldn't say bad data log, but that's what a data log that means that you need to do some work looks like. You can see look at what happened with the closed loop compensation. See what happened? It was rich, and it was trying to compensate. So it's trying to take fuel out. And then let me see, is my learn there? Let me turn the current learn on. There. That's the learn line right there. I think it's red. That is the learn line. So you can see how much it compensated. And the learn only is some percentage of that because it doesn't want to overlearn the way that it's set up. There's some sort of an algorithm, I'm sure, where it doesn't take out as much because it doesn't want to overshoot. So it kept learning, but it just wasn't enough. I had to go in and modify this. So let's see, what was our closed loop compensation at? Closed loop compensation is minus 9%. So you don't, get this to focus. You don't want to see numbers like that. You don't want it compensating 9% all the time because remember, it's kind of doing this on a curve. So that entire time that this is dropping down where this is wrong, you're losing all that. You're losing performance that whole time. Whatever this duration is probably a few seconds. I don't know, maybe longer. You're losing a lot of performance there. So you don't want it to look like that. So let me just pop the program open real quick and I'll just show you the areas that I fixed. All right, so here's my base fuel table. This is the base, what the graph looks like. This is a 3D graph, and you can spin it around. It looks a little bit funky, but this is what my engine wants, okay? It is just too rich in this area right here, which is in a certain RPM range and a certain map. Okay, so this is map coming towards us would be wider throttle, going away from us would be lighter throttle. This is the volumetric efficiency, which is 100% is maximum fuel, or over 100% is more fuel. This way is less. This way is less fuel. This is RPM. This is 0 or idle all the way up. Right. We were very fat in this area, and we were fat in this area. I brought both of those down, and then I smoothed it because what'll happen is you're going to select some cells to change. And if you guys want to know how to do this, go watch another video on it. Like I said, I'm not teaching you how to do this. I'm just telling you what my engine wanted. Okay. You select certain cells and you drop it a certain percentage. I decided, I think, like I said, I dropped it 8% or 7%. I forget exactly. I dropped it and then you smooth it. And I just do smooth all. You could smooth select it, but then you got to select a range. I just smoothed the whole thing once after I changed it, because what happens is otherwise you get a knee, what you'd call a knee, where it drops off, right? All of a sudden you're going to have some big change because you just changed a set of cells 5%, but the other ones curve in to it, so you end up with a kick in it. You don't want that to happen. So after you get through modifying it however much, by looking at the data log, you can tell how much you want to change it. Then you just smooth the whole thing, and it'll bring it in pretty good. Look, I'm no expert with this. This has been trial and error. I don't tune vehicles for a living. I've just done it a few times. So anyways, that got my data log kind of straightened out. The learn table is just the values that the learn table has. You can go to the learn table and transfer the learn to the base and then smooth it one time. Like I said, there's other videos on that. Here's my air fuel ratio table. This was curved by a friend of mine on the Vintage 6 forum. He went ahead and took care of this for me because he already had this from his sniper setup a while back. I think I might be a little bit fat still. I think in general, the fuel economy is not where it should be. It's getting, I don't know, 18, 20 out on the highway, and it's getting about 14 around town. I would expect more. However, the thing seems to be really happy, and it's running really well. I mean, really, really well. So I'm probably not going to monkey with it. I don't care that the fuel economy isn't great. I would expect more out of fuel injection, and I bet if I put it up on a dyno and actually had somebody professionally tune it, they could probably get it to where it's running max horsepower and fuel efficiency. But seat of the pants, it's pretty damn good. So that's my air fuel ratio table. Acceleration enrichment, I really didn't change anything here other than I changed the basic version of this, which kind of overall changes it. 2 points like I talked about before. I didn't change anything else in there, I don't think. Timing map, this is my timing map. Again, this was custom set up by a friend. Let me see if there's anything else in here that I monkeyed with. Mainly, like I said, I was only changing the base fuel. Everything else seemed to work really well. This timing curve seems to work best. Seems to work best in my application. Like I said, this thing doesn't like a lot of timing. It really doesn't. Under load, you can see it really. Under heavy load, it never exceeds 27, 28 degrees of advance. I had it far beyond that. I think I had it about 32 degrees, and it did not like that at all. Let's see. I didn't play with startup enrichment. I didn't play with fuel control. I leave DFCO turned off. I don't like DFCO. This is something that the Phytech has as well. It's supposed to save you fuel under deceleration, but it can also cause it to want to stall too. So I don't know. It's just a feature that I don't need. Let me see if there's anything else in here that I monkeyed with. I don't think so. I think I pretty much covered it. So, this is like a 1,000-mile review. I'm very happy. I'm still tweaking on it, just like you would with a carburetor. It's like jetting your carburetor. You just keep playing with it till it feels right. Overall, 0 problems. The fuel pump's still silent. No problems there. I've kind of gotten to where I'm driving it and not worrying about it anymore. Anytime you do a whole bunch of work to anything, some people like me, I'm kind of neurotic. I tend to worry about stuff. But in general, it runs like a regular everyday car. It sat I drive it pretty frequently. I drive it to work 2-3 times a week at least. And that's, 20 miles each way. No problem. It's absolutely reliable. It runs fine. Now that I rebuilt the rear end in it, or had the rear end rebuilt, that video's coming out this upcoming Saturday. I don't know if I'm going to release this before then or not, but I had the rear end rebuilt, and now it's so quiet inside. So it runs great. I highly recommend this system if you're going with a stock setup or you have a mild cam in your 200. This fuel injection system's perfect. It'll do up to 175 horsepower, so it can handle a little bit more than stock. If not, you're probably going to a 2V anyways, or a 2-barrel. But same setup if you go with the 2-barrel. Same software, practically the same file. So, rev limiters. I wasn't going to change this because I didn't care. I wasn't going to put a rev limit on it. And the guy that was helping with the tuning, he changed it to 5,000 RPM, which is fine. I didn't set it up on purpose because I just didn't care, but he went ahead and he set it up. So that's about what these things tap out a little bit before that when they're stock. All right. I don't think there's anything else. So this is probably way too long already, but like I said, it's a 1,000-mile review so far. Very happy. No problems whatsoever. And I've been driving it quite a bit, under a lot of conditions, and it's been great. So, all right, folks, I guess we'll catch you next time.